In this module, we're going to start learning about the atom structure, how electrons, protons, and neutrons are interacting with each other when they come together to build an atom. And then we'll move to understanding how different electrons are distributed within the atom, or what we call the electronic configuration. And from these electronic configurations, we should be able to understand why sizes of atoms of different elements vary and how this variation in size affects other atomic properties, including ionization energy, electron affinity, and electronegativities. And these variations in atomic properties should help us understand and predict different type of bonding each element could be involved in, covalent bonding or ionic bonding. And from that, we should be able to learn how we can construct molecules from atoms, and then what shape these molecules take. And based on our knowledge of the molecular shapes and atomic properties, we should be able to understand molecular properties. Specifically, we're going to focus on polarity and how that relates to the intermolecular forces, which is the main factor that determines macroscopic properties. So we're going to move from our basic understanding for the atomic structure all the way up to understanding macroscopic properties that we see in daily lives for different substances. Our understanding for different substance composition was very closely related to the substance energy interaction. We need to learn the different types of energies that we encounter in nature. First form of energy that is of great importance to the atomic structure is kinetic energy. And there are several types of kinetic energies that are basically associated with the motion of your substance or the motion of your particle. And that includes simple mechanical energies. Even electrical energy is a kinetic energy because it's a motion of electrons in a conductor. Thermal energy is a kinetic energy because it's basically vibrations of particles in your substance. And that is really important in the context of understanding the atomic structure, because within the atom, electrons are orbiting nuclei. So that's a motion that has kinetic energy. Second type of energy of interest to the atomic structure is potential energy. Potential energy is any form of energy that is related to position. And that includes gravitational energy that comes from the gravitational attraction of the Earth to different particles. So it's going to depend on the position of the particle or the object with respect to the surface of the Earth. And electrostatic energy, which is basically an electric attraction between two different particles. So again, it's going to depend on the distance between these two particles. And lastly, electromagnetic energy, which is basically the energy associated with any radiation, including light. And we're actually going to focus on this last type of energy, which is the electromagnetic energy, because thanks to the light-matter interaction that we were able to understand how the atom is built up and how electrons and protons are communicating or interacting with each other. So when a substance interacts with light, there are two possibilities. One possibility is when you heat any substance or any particle to a high temperature, it starts irradiating light with all frequencies in what we call continuous spectrum. The other possibility happens when light interacts with an atomized sample, a sample of atoms of a single element. In this case, atoms themselves will start emitting light or exhibiting a spectrum. That spectrum will contain very specific frequencies or very specific lines. So that's why we call it line spectrum. So we'll see how understanding these two different phenomena is going to help us understand the composition of the atom.